Okay, so in working with data, the main tool that you will see yourself using to manipulate data and work with different kinds of data in Python is the pandas, pandas in Python. Now, pandas is used to manipulate data structures. It's used for working with different kind of data. It's not part of the standard Python library. And that's why anytime you want to use the pandas library to work with data, we have to import it. So there are two aspects that you will be using pandas with. One is the data frame, and the second one is the series, is the pandas series. So those are the two things you'll be working with. Okay. Now the question is, what is a data frame? In a traditional way, a data frame is a series of rows and columns, okay? And the series is just a single column. Just a single column of your data frame is what we call the series, okay? A pandas data frame consists of rows and columns, but your series is just the single column of your data. Okay, sorry, excuse me. All right. So to rephrase what I was saying, that when we talk about a data frame is a series of rows and columns. But a series is just a single column in that your data frame. And I will just quickly show you how to create it in Python. So first thing, you have to import the pandas library, like I told you, because it's not a part of the standard Python library. So we have to import it. So one way to import it is import panda. We normally use this alias PD. It's not a must, but that's like the standard. That's the tradition. So you import pandas as PD. That's just the short form, so that you don't keep on writing pandas in full. That's why we are shortening it as PD. Okay. So if you want to create series, call that PD, put dot and press tab. It will load, and then you can scroll down, and one of it is the series. Just so the series, which is this. I'm sure you also see data frame there and so on. So when you do that, you open, and then you open a bracket, you can put your list there. Whatever list you want to put there with your data, put it there. This name, we are just trying to name our series. It's optional. If I do this and run it, it just gives me the data back, 41, 45, 142, 38, and 13, and the index of each of those data. But just to name it, in case you want to access it, that's why we name it. It's optional, but you can name it whatever name you want. Okay? And then if you do that, it gives you the same thing. Just give us the column, the name, that name counts, and then the data type. So that is how to create a series in pandas. And then, so we move on to how to load your data. Most of you are already aware of this based on the free training, the last training that we did on applied machine learning with Python. In your Canvas notebook, I put the notebook. I also put the class data there. So try and download it, because this data I'm using, and the one you will use in the exercise, is in that zip folder in your Canvas dashboard. So please download it so that you can use it for the exercise. All right. So this is the directory where I stored it. So you can just copy the directory that you are going to store it and then use it there. Okay. Okay, so this is the data I'm working in. Like I told you, the data you will use, this same data, and the data you're going to use for the exercise is in your Canvas notebook. It's stored as class data in a zip folder. So please download it and unzip it into your own computer so that you can work along or even during the exercise. So now this is the link. Now, because I'm using Windows, I know for Mac, this will not be an issue for those of you using Mac, but for those of us using Windows, this, what do we call this? I think this is the /, right? I usually mix it up, forward and backward slash. So this, like, if you use it this way, and then to load your CSV, because this is a CSV, if you put your PD, since we've import pandas as PD, put dot and press tab. We then read CSV. If you're working with Excel, you can use the read Excel. If you're working with HTML, read HTML, JSON, read JSON. But since it's CSV, we use this. And then if we put the URL there, since I already put it, it's not going to work. And this is because the problem is the Windows, not because it's wrong. So it's either you change this to this slash, or you just put R there, okay, before that, and then you can run it, and then it will work. So let's see what the problem is. I think I made a mistake here. This should be read CSV. So it will, what is the problem? Let's see. Maybe I've changed the directory. So let me copy the directory. I might have changed the directory. Training recordings, Gapminder. Oh. Sorry. Okay. Sorry, can you please see my screen? Hello?
Yes.
Okay. So if
yes, sir.
And then it will work. So this has actually loaded. So just note that if you're using Windows, make sure you put R before the directory, or you just change this / to backward slash, or maybe I'm mixing it up. Okay, so that's about that. So then we can now start exploring our data. So when you, as a data scientist or as a data analyst, when you have data, you don't just move ahead to start, let's say, building a machine learning model. Let's say that's the end goal, that the end goal is to build a predictive model. However, when you get the data, you can't just move there straight. You can't just start by building a machine learning model, because most all of the machine learning model work perfectly well when your data is in the right format, when your data has no missing values, because there are many machine learning models that will fail when your data has missing values or when your data is in the wrong format. So because machine learning models or machine learning algorithms, they thrive on data. It's actually data. Without data, you can't build a good and robust machine learning model. So there is a need to first explore the data. In fact, while exploring the data, you will see some things that you were not pre-informed, you were not even expecting. Like, you can do a lot of calculations, a lot of feature engineering, a lot of insight into the data to see what is going on. So one of the first things you need to do is to check the first few rows, at least let's say the first 5 rows, to be sure your data actually loaded very well. So what you can do is take your data, I save it as gap_df, check the first 5 rows using the add method. The add will just give you the first 5 rows. If you do that, that gives us the first 5 rows. I'm working with the Gapminder data set. Okay? So this will give us the first 5 rows. So we can see some of the things we have there. Oh, we have country, continent, year, life expectancy, population, GDP per capita. And then we can see some things that, okay, here we can see that our data loaded very well. So you can also check the dimensions of the data. By dimensions, I mean how many rows, how many columns do we have in the data? You know, traditionally, people use Excel, and Excel is great, it's fantastic. But the problem why the focus is shifting to programming language now, be it R or Python, is because while you are trying to work with your Excel, you can mistakenly punch some letters on your keyboard without knowing, and then that will affect your calculations. Also, you will have to keep on performing the same thing over and over and over again if you are doing the same calculations on different columns. Whereas in programming language like Python or R, all you will know if there is an error, if there is a mistake in the data, because you're going to explore, you're going to work with, you see. Because if you're working with millions of rows, it might be difficult for you to note the error if you're working with purely Excel. So, and then it will also work, the work that will take you few minutes. You know, there was one person that that is working with an oil company in Nigeria here. So he has a data, like the statistician, but mainly he's working with data with most of oil companies. Like they send the data to the organization, and then so he normally use Excel for most of his work. He's my very good friend. And then, but he joined us for the applied machine learning with Python that we did in June. And we were working with Pandas, and it was wow. So what he could do with what he has been suffering and be wasting time doing with Excel, he can also do with it. 3 weeks after the training, I was just, midnight, and I was still in the US, and I just saw his call, like he was just jumping around, like what usually taking 5 hours now is taking him like less than even 20 minutes, because Pandas can actually do most of what you are using Excel to do in terms of manipulations. So what I'm trying to tell you is that a programming language like Python or R, we make your work fast, efficient, and even standard. So back to working with this data. Check the dimensions of your data, like how many rows and how many columns. So your data, and then just do that with the shape, okay, with the shape attributes. I call it attribute. If I call it method, then it has to have a round bracket in front of it. So that's why, like the head is head method. But this shape is just an attribute. So you don't have to put, if you put round bracket there, it's not going to work. Okay? Because it's not a method, it's an attribute. All right? You can also check for missing values. That, oh, this data looks perfect here, but there might be missing values in the data. How do we do that? So take your data frame. This is the name of your data frame. You can use isNA. It's a method. So put this. If I run this way, it's just going to give me back the data frame and tell me false. Why is it telling me false? It's telling me false that this row has no, this spot here has no missing value. However, this doesn't really make sense. So let's sum it together. Because in Python, false is 0, true is 1. So when we put sum, it's going to sum all of them across the rows. It's going to sum them together. 0, false is going to be like 0, and true is going to be 1. So if we do this, then you have all of this. So it's telling me that in the country column, there is no missing values. Continent, year, there are no the missing values there is 0. You can use isNA, or you can also use isNull, because null means, you can see, so either you use isNA or isNull. Those two ways to check your missing value. So just sum it so that you can have the aggregate of those missing values. We can also perform some simple statistics on the data, okay, like gap, DF. You don't need to memorize all of these things I'm using. Like I told you, once you put the press tab, it's going to tell you the method you can apply there. You can apply, so there is a method called the describe. That gives us the statistics of our data. However, by default, if you put Shift Tab, it tells you how to use it. By default, it will only give you the statistics for numeric features, numeric columns. The columns in your data frame, in data science, we call it features. Is it how you call it variables, columns, or features? So anytime I say features, I'm talking of each column. If I say observations, I'm talking of each rows. It's good for you to be used to most of these times because these are the terminologies they are using in this field. Okay, rows, it means observations. Columns, it means features or variables. Okay, so by default, if you use the describe, it will only give you the statistics for numeric values, numeric features. However, so if we can run this way, it gives us, you can see now, out of all the columns, we do not have the country and the continent there. It only gives us the count, the mean, standard deviation, minimum, lower quartile, median is 50%, upper quartile, and maximum for the numeric columns. However, if you want to see all others, okay, there is a feature, there is an argument here called include. Is by default is none, but if you put include equals to all, okay, then it gives you for everything. You can see, but you know, the highest you can get from a categorical variable, when I mean categorical variable, I mean string, is the count. That's why it doesn't give you, because every other thing, you can't find the minimum or the mean or minimum of a string or of characters. You can only get that for numbers. So that's why by default, it gives a numeric. But if you are interested in the categorical, you can only get the count. So you can see the count, the unique values. That's what you can get. So, but we don't really need it. So you can just use the default, okay? You can also check the column name because there are sometimes you have many columns, many features in your data, and you want to know if those features, if they are, if those column names are actually good, like they are stored in a good way, standard way. When I mean standard way, because by the natural standard is that your column names should not have spaces between them. But there are sometimes the people who collected the data might put space, like life space expectancy. No, that doesn't really make sense. But so that's why it's good to check the column. So if you want to do that, gap df, put dot and press tab. Let's see if we have an attribute called columns. Okay, we have it there. So if you press it, if you run it, it gives you the column here. For this one, we have just 6 columns, so it might not really be, you might see that directly when we did all of this. But in case you have many, a country, continent, year, you know, so that's how to check the column names. Let me recap what I've talked about. I have talked about to load your data into Pandas using the Pandas read CSV. If you're working with Excel, we have the read Excel. Just put tab and press, put dot and press tab in front of PD, and then you will see all the methods you can use. I've talked about to check the first 5 rows using the head method. I've talked about to check the number of rows and columns using the shape. So here we saw that we have 1,704 rows and 6 columns, 6 features in our data. The rows are called observations. The columns are called features. I've also talked about how to check for missing values using the is NA or is null. But do put a dot sum after the is NA or is null method is to aggregate it, because in Python, false means 0, true means 1. I've also talked about how to perform simple statistics using the describe method. And I said by default, the describe method gives us the statistics for just the numeric values, okay? So, and then finally I've talked about to check the column names, the features you have in your data using the columns attribute, all right? Then here also you can check the data types of your data to know whether they are numeric or object. Object there means strings. So we can, our data frame, there is a method called the D types. Or if you don't just put tab, dot, and tab, I think we have the D types, yeah, attribute. So if you do that, it tells you the data type of each of your feature. So we can see that the life expectancy is float. Don't worry about the 64, it's just telling you that it's 64 bits. The main thing is the float. Same thing with the integer. The population is integer. Then country is object. Object means strings, mean letters, strings. As we saw here, Afghanistan. So that's continent too. That would be object because they are strings. Okay. Any question before I move to how to subset our columns? Any question? Or are we good? Can I move on? Hello?
Sorry, please. I think I have a question.
All right. Okay. Go ahead.
Hello?
Go ahead. Go ahead.
Okay, I should go ahead.
Yes.
Yeah, the beginning of the, from the beginning of the screen, if you can scroll up, please, where we add this series. Yeah, thank you very much. This part. So looking at the PD series, I mean, now the arguments passed. So we have what do we call this in Python? This array. This is array. Then we have second argument, which names it, right? So now for the array part, I just want to ask that, do we have to literally provide the numbers like this, or can we also, I mean, all these numbers, put them, create them as a list, and then use the name instead of particularly writing it out this way? I don't know if I'm clear.
Okay, so let me, I just showed us here how to create it. It doesn't mean that we have to create it all the time, no. This is just in case you are working on your own, you want to create a series. Like I said, a series is just a single column of your data frame, but this is how to create it using pd.series method. But for instance here, I've seen, this is my data frame. So if I want to get a series like gap df, if I subset, that's the next thing I wanted to talk about. But if I subset just the country column, this is a series. And if you want to know whether you are correct, let's save it as country. Okay, and then let's check the type of this country, type of this variable country. It tells us, you can say pandas called series. So you don't have to create it. I'm just showing you that a single column of your data frame is called a series in Python, in Pandas. So if you're working with your data, if you have a data, selecting just one column, that column is called a series. So, but if you want to create it yourself, that's why I show you here. You don't have to. I don't know if I answer your question.
Okay, so now that we have provided the series as country now, I mean, we have named it country underscore df, then can we go inside the arguments, the first argument, and then provide country underscore df, and then the second one as name?
No, they are two different things. These are two different things. This one, you are creating it. This one, you already have a data. You are subsetting it. So you don't have to do that. Yeah, they are two different things.
Okay, that answers it. Thank you very much.
Okay, so subsetting, now let's move on how to subset, how to subset our columns, okay? How to subset our data. So the first one I want to talk about is subsetting our columns by name, okay? So like I've already shown this there, that suppose I'm only interested in the country column alone. There are two ways to subset your data. One is using this format, which I already used there, like your data frame, your square bracket and put the column in quote. Or you can as well call the data frame, put dots, and just put the column name, country. This will also work. This will do the same thing. However, this second approach is it will only work if your column name does not have space between them. Like if they set a column name to be country space, maybe Africa space. If there's a space between it, you cannot use this dot method. You can only use the square bracket and put it in column, in quotes. So, but these are the two ways to subset column names or feature. This put it in code, or this other one that I showed you that put dot and put the column name. So these are the two different ways to subset it. You can also show the last 5 rows of this country, because here I showed the first 5 rows. Doing this, the last 5 rows, you have to use tail. Okay, so this gives us the last 5 rows. Okay, and then you can subset multiple columns, but if you want to do that, you have to pass those columns as a list into your data frame. That's why you use double square brackets. If you are selecting more than one column, more than one features in your data, then you have to use double square brackets. So here, I'm selecting the country, continent, and year from this gapminder data set, and I want to save it into a variable called subset. So that's why I'm using double square bracket. Then I can, check the first 5 rows. The reason we're only using the S so that your data doesn't fill up your screen. That's why we're just checking the first 5 rows. Okay, so I want to I've talked about how to subset the columns using the column names, like using square bracket and putting the column name in quote, or using the dot and specify your column name. What about if you want to subset that data using the rows? There are 2 ways you can do that. We can use the loc method, LOC, or the iloc method, ILOC. However, these 2, in most cases, they will give you the same thing. However, there are some cases where they are different, and I will show you here, because we use loc to subset our data based on the row label, like this 0, 1, 2, 3 row label. Like if we name this label, this row 0, 1, 2, 3 are called the index. However, if we name it like we name this index something else, we can use the loc. The integer loc, the iloc, is the one that use this index really. But in most cases, we can still use the index with the loc, but they are different in some cases. You will see it in another example that I will do. So using the loc method, suppose we want to select just this first row. We want to see the data in our first row, in the first row of the data, or in the first row of our data frame. So you can call your data frame gap_df, put dot, and then put loc. Then because Python is 0 index, that's why we're having 0 in the square bracket. So if you do that, this is actually the first row. Country, Afghanistan, the continent, Asia, the year 1952, life expectancy, population, GDP per capita. If you want to check the 100th row, that's index 99. So gap_df, put your loc, and then put 100 actually, but this will give us, no, that should be 99 since it's starting from 0. Okay, so this is the 100th row. Country is Bangladesh, continent Asia, like that. So that's how to use the loc. So the question I'm having here is that, how can we get the last row from the data frame by subsetting? I'm going to throw this to the class, and I will just leave 30 seconds for us to deliberate on it. And I'm watching my time, 30, or let me put it 45 seconds. So I will allow just 2 people to comment. So if you want to, this is your chance. How can we get the last row from the data frame? By subsetting. And I put alternative way too. So you have 10 seconds to give your input. Yes. What do you think? Anybody, please?
Basically,
Yes.
I think if we use the tail function, so when the tail function give us the number of the last row, then we can come back to use LOC. Scroll down, so it's on 1703. So we can go to gap. We can now use scroll up a little. Yeah, so we can now use 1702.
Okay. 17002.
702
3. Okay.
03.
Okay. Yeah. Okay. That's nice.
Yeah.
Yeah. Okay. Yeah. That's one way which you are correct. Yeah. That's why I love program. There's no one way to get it. Okay. So I mean, this is correct. So this is one way, and that's smart of you at least to think at a spot. Get the tail, and then use to see the index, the last index, and then use that to subset it. That's correct. I mean, I'm happy because you're able to think on a spot and to get that. So why did I even do that? So that's that. An alternative way, instead of using this second one, still using the tail. Since it's tail, what if we put what if I put, let me see 0. This is not what I want to do, actually. Okay, so this is not what I want to do anyway. So let's agree with Mr. Davis, and then let me show you another way. Another way is to first this same thing he did, but by specifying, like, get the rows, like, oh, we know that to get the shape of our data, gap df, if we put dot shape, that the shape normally give us the dimension, the number of rows and columns. So, if we run this, that shape, it normally give us the rows and columns. And then if we put this, if we subset the shape by 0, since Python is 0 index, this will give us the total number of rows, which is 1704, right? So if I do this, and then save this as, let's call it row index. I guess this is a longer way. Then my last row index should be this, my row index minus 1, because it's by 0, Python is 0 index. So the same thing it did, but I just don't want to use, I'm putting it in a program, in a programmatic way, so that we don't have to keep on putting the number. Because what if the data is another data is 1 million? That means you have to check the tail, pick the last number. But this way now, it will work for every data. So I'm doing exactly the same thing Mr. Davis has said, but putting it in a programmatic way. So this one will give me, the first row will give me, the first line will give me the number of rows. This we subtract 1 will give me the second, minus 1, because it's 0 index. Then we can now use this to subset, like you did here, gap underscore df, good log, and then use this to subset my data, last row. And then this should give us that. This should give us, you can see, give us the same thing as that. So the one he said is correct, but I'm just putting it in a programmatic way. So that's one way to do that, okay? That's correct, I love that. So, and I said, okay, what if we want to select the first 100 and 1,000 rows? Okay, we can still use the loop, but just the way that I said that if you are selecting multiple columns, you have to put it in double square bracket. The same way, if you are selecting multiple rows, you have to put them in square bracket. Use the loop, put the indices of that you need. The 0 stand for the first, 99 stand for the 100, 999 stands for the 1,000 row. So if you do that, you will get this. So this gives us just the first row, the 100, and the 1,000 row. So that is how to use the log method. Okay, the log function on our data to subset the rows and the columns. So we can also use the ilog. So I put here that the ilog does the same thing as the log, but ilog is used to subset our data by the row index number. And note what I put. I said that the ilog and log behave exactly the same way for this our example, but it does not necessarily have to be like that, because it's working because our index in this case is the same thing as the index as the row label. But in cases where it is not, the result of your ilog will be different from your log. You will see it as we move on. So if you want to get the second row, just put 1. The first row, put 0, then you will get it. Now, what log could not give us, ilog can give us. Like log couldn't give us the last element, the last row. Like if you do like the last row, log couldn't give us the last row directly. We have to manipulate. Like if you do log, last row, if you do -1, it's not going to give you. But because it's a -1, it's not in the row. But ilog can actually give us that. Like the last row, put your data frame dot ilog and put -1, and then this will give you the last row. So that's to tell you that in some cases, the result of log and ilog are actually different, because ilog is working with actually the index, or this index indices here, the index number. But log is not. It's just that it's working for this example. Why? Because the index is same thing as the row label for this case. All right. So we can also subset multiple rows, like the first, the 100th row and the 1,000th row using the ilog, just like we did for the log method. So here, I just want to mix it up like, oh, let's say we want to use both. Like, okay, we want to get all the rows for the year and population columns. Remember when I was teaching list that we were using column, like column, to subset our list. The same way here, call your data frame, log, put your square bracket. Now, I said it here that what comes before, like if you, what comes before the column stand for your rows, what comes after the column stand for your, after the column stand for your columns. Like if I want all rows, I'll put column, so, and then put comma, then specify my columns there. I want the year, and then the pop columns. Okay, if I do that, it will give me the data frame, all rows for my year and my population. Suppose I just need the 3rd row to, let's say, the 10th row. I can do that too. So you can see it starts from 3, it ends at 10. So it's giving me from the 3rd row to the 10th row. And you can do that for any other rows too. So, but if you do not specify this number, I just put column, it will give you all the rows. So you can also use ilog. So if you are using log, you can see we are specifying the column names. Now, using ilog, if you specify the column names, it will not work. You have to specify the index of the column, like the year. The year is 012. That's why we're putting 2 here. The 4th one, like, oh, sorry. Okay, the 4th one, like 0, 1, 2, 3, 4, that's the population. And the -1 stands for the last column. So that's why, because I'm using ilog, that's why I'm specifying number, because it's working with index. But if you're working with log, by default, you have to specify the column names. Okay, so that's that. So that's what I did here. And that gives me that. You can check the head if you don't want to give, don't want to get everything, just give it the 5 rows. Okay, all right. So, and we can, I think I've talked about this. You can still use the ilog. This column will give you all rows. This column 3 will give you all the first 3 rows, the first 3 columns, like this. It gives you the first three columns, the country, continent, and year. If you want just the first two, put 2 there. It gives you 0, 1, that's just the first two. If you want everything, just put columns too. That gives you everything there. So that's how to subset using that. And we can also subset the first, some rows and then some columns. Here, I'm using iLog. This week, the first bracket gives me the first row, the 100th row, and the 1000th row, comma. The second square bracket is to select the columns. Okay, once you put comma, the next thing you specify is the columns. And this is giving me the first column, the 0, 1, 2, 3, the fourth column, and then the sixth column. Okay, the last column. And that's why I'm getting this. Okay, any question before we start calculations on our data frame? On any question on log and high log? We have 30 seconds for that. Any question, please? Or are we good? Can I continue? Hello?
Mr. Kenny,
Yes.
I think maybe for easier process, I think it's easier to use iLook when we manipulate data to compare to LOC. I'm just thinking, because for me, that I've not been programming environment before, I would like to, maybe for now, not to know so many ways and then to just stick to a particular one. I'm thinking probably iLook will be easier for me maybe to manipulate data and all that compared to LOC. From your experience, what is that right?
Well, I would say not really, because like I told you, I said, for you to use iLook, that means you need to know the index, the position of that column name. What if you have like 100 column names? So to use the iLook to subset your data, you have to go into your data and look at what number is this column, this feature. I have to specify to know that. You can see, even me, I don't know if for this is, I have to scroll up to say, okay, here is 0, 1, 2 before I put 2. Before I put 2 here, I have to look at which column is 4, 0, 1, 2, 3, 4, the population. But the log, all I need to do is to put the column names like year, pop.
Okay.
That's it.
Okay.
And that will give us. So the two, you have to know the two, because the two are used for different purposes. It's just that in some cases they give you the same result, but in most cases they are not. So they have this log, iLook has its own advantage, log 2 has its own advantage.
Okay. Okay.
Okay.
All right. Thank you.
Yes, sir. So let's look at how to do some calculations on our data frame. Okay. Now I put a question here that find the average GDP per capita for each continent. Find the average GDP per capita for each continent. And then, so that's the question. Now, because you see for each continent, so that means we have to group by the continent. So there is a group method in Pandas called group by. So group by continent. Why am I grouping by continent? Because the question says for each continent. So group by the continent, and then which feature do we want to perform calculation on? It is GDP per capita. So that's why I'm selecting that column out, GDP per capita. And to select, you have to use square bracket. The round bracket in front of group by is because group by is a method. Remember I said that every method must be followed by a round bracket. So put the continent because we want to group by the continent. But the feature we want to perform calculation on is GDP per capita. So that's why you are selecting it out. And to select out in Python, you have to use, in Panda, you have to use square bracket. So put the name, which is GDP per capita. What do we want to calculate? Which calculation? We want to find the average, which is the mean. And that's why I'm putting dot mean. And then you run it, you can get this. Suppose you want to do the median, you can also do that. It gives us the median. We can also get the sum. And depending on what we want to do, okay, and it gives us the sum of the GDP for each continent. But what we are interested here is the average, the mean. So I'm just showing you all of that to tell you all the different calculations you can do. So anytime you hear for each continent, that do this calculation for this feature for each continent, if that means continent is a categorical variable. So you have to group by it, select out the column name, the feature you want to perform calculation on, and then what calculation mean. That's why you put dot mean. Okay? And I put here that we can also calculate the average GDP and average life expectancy for each continent. Since it's for each continent, that tells you that we can still select our group by the continent. Okay, then since we are, which features are we calculating on? GDP and life expectancy. So we have two. So you can put those two in a list. We have the GDP per capita, and then we have the life expectancy, Then what calculation? The mean, and then you have this. So you have this. So this is the continent. Then it gives you the GDP per capita and the life expectancy for each continent. So you can see that's how to do some of the calculation. You can select more than 2 columns. It's telling us that in future this method may not be duplicated. Okay, so but this is how to do that, perform those calculations. So you can see that now. So suppose you want to find the frequency of unique countries in each continent, because in each continent you have many countries, but there are duplicates here. So suppose you are interested in just the unique countries there. Okay, so because we are still dealing with in each continent, we group by the continent. We need the countries. Okay, so that's why we select out the country using a square bracket. But we need the number. Frequency is the number of occurrence of a particular thing we are interested in. So that's why we are using n unique. Unique is because we're interested in the unique one. So there is a method called n unique. So after you select out the country, just perform that, and it will give you the number of unique countries in each continent. So in Africa here, we have unique countries that will be 52 that are represented in our data. America's 25 and so on like that. You can also count you can also get the count of each country in each continent. This one is the unique countries. This one will give us all the countries. It may not be unique, it may involve duplicates. Okay, so you can see it's telling us that, okay, in Africa, Algeria 12, Angola 12, Botswana, and all of that. So that's when you use the value count. So the value count gives you the number of each categories in your data. But the unique, this one is not involving duplicates. Okay, that's why we're using n unique. So just take note of that. The value count gives you the number of the number of each category in our data. All right. Any question before we look at the second to the last aspect of our of this class? That's the data assembly, like concatenating data and all of that. Any question so far on the calculation, the group by 30 seconds? Any question? Can I continue?
Hello, sir.
Okay, go ahead.
Hello, sir.
Yes, sir.
Yeah, you will see that there are some methods. Most of these methods we are using, they are inbuilt, like a unique continent, group by, and all that, and all that.
Mm-hmm.
I want to ask, is it by version or any Jupyter notebook has all these things?
This has nothing to do with Jupyter Notebook.
Pandas. Panda.
Yes. Yeah, these are methods that come with pandas. Mm-hmm.
So it has nothing to do with version.
No.
Downloaded. Okay.
No.
Thank you.
Yeah. Okay. So data assembly. And when I mean data assembly, it means that suppose you are working, you know, those of us do, I mean, as a data analyst, or some of us who have been working with data, there are cases, especially if you are working with SQL, maybe one of these days we'll do small training on SQL, on how to work with databases. Now, most, or even your Excel, you know, sometimes data are stored in different sheets, like different, or you have different data, different tables for your data. So you have different data frame. But these data frames are related in some ways, and you want to merge them. You want to combine them together. So that's what I mean by data assembly. And one way to do that in Pandas is using the concatenation method. Because concatenation, even English, right? Concatenation means to combine, to merge. Okay? But before I look at concatenation, let me quickly show you how to create a data frame. In most cases, you will not. You already have the data frame. But I just want to show you how do you create data frame. Like I showed you how to create a series. So to create a data frame, there is a method called the data frame with capital D. Just put your alias, PD, put dot, and you press start. You will see the data frame there. So suppose you have data stored in a dictionary. Sorry, can you be muted? You ask questions during the when I leave room for questions. Please, can you be muted, please? So, suppose you have a data. This is a stored in a dictionary, D1, where you have the keys stored as A and the value stored as a list, like that, B, and all of that. So this first one is a dictionary, D2 is another dictionary, D3 is another dictionary. So if you want to create that data frame in Pandas, you can use the pd.dataFrame, and then data equals to put the, I want to do each of them, create them as a data frame separately. So that's why I put D1, that's the first dictionary, save it as a variable df1, do the same thing for df2, df3. So if I run this, this gives me, I already have 3 data frames, df1, df2, and df3. Now, suppose these are the 3 data frames that you have and you want to combine together because they are related. They are, you want to merge them. You can use what we call the concat method. So if you put your PD dot and press tab, you will see the concat method. That stands for concatenation. It's a method. So you can press shift tab to see the documentations and how to use that, some of the arguments there. Okay? And then, so put your data frame in a list because you have multiple. You have df1, we have df2, we have df3. Those are that's my data frame. I can even check it to be sure my data is working. So these are the data. So we have already combined these 3 together. Now note that all these 3 data frames have the same column names, A, B, C, and D. Note that. So we are assuming now that your data frames have the same column names. So we are working with that assumption. We will look at when you do not have the same column names. Okay? So this is how to combine them, to concat them together using the concat method. All right? And then we can keep on working with it like we have been doing, like, okay. But take note that because you are concatenating them, look at the index 0, 1, 2, 3, 0, 1, 2, 3. The index is not stored correctly. So you may not really know the disadvantage of that. Now, but look at, we want to select, now this is where I want to tell you the difference between, another difference between the log and the high load. Okay, so you want to subset the third, you need the third column. So you put your data frame.ilog and put these 3, you get this. So I put a question that what happens when you use the log? Let's see what happens. .log and put 3. So if you do that, see, it gives you, it goes into the data and gives you everywhere you have the row 3, row with this label 3, and it brings it out. Meanwhile, that's not what you have in mind. That's not what you want to do. You only need the third row, but it's giving you every row that has this index 3. So that's why I told you that the log and the high log are not actually the same. They are only the same in the first one because of our index, and the same thing as the row label. Okay, so how can you resolve that? There is something we call, you can ignore the index. Okay, so let's see. What if I put my df, okay, let me copy this back. There are two ways anyway. I will show you the two ways. So let me use this data that we have, df underscore com, and then put reset index. Okay, so reset index. Let's see what we're going to have. So I don't really need this first one. This is the one I need. But the main way to do that is, the reason this is giving me the previous one is that it's just copying the old data frame. It's giving me the previous index and the new index 0, 1, 2 to 11. I don't need the second one. However, to resolve it while you are loading it, let me tell you the argument, that the parameter that actually calls this. So put your cursor there and press Shift Tab. If you open it, this ignore index by default was set to false. So if we set it to true, that ignore index, if we set it to true and then do this, you can see. So it corrects the index. So if this is correct, then the log and the iLog will give you the same results. The log will give you this. You can see this is the result of the iLog. And if I comment the iLog and then do that for the log, this will give you the same thing like that. So it will give you the same thing if the index and the row label are the same thing. So the one way to solve it is to ignore the index, set it to true, because by default it is false. Okay? Now, I think I'm not going to move into missing data because I want it to take some time to work during the breakout. But let's quickly finish this, the append, adding columns and all of these ones. Okay? So we can also use the append method instead of the concat. Like I put here that the concat method is a general function that can concatenate multiple things at once. But if you just needed to append a single object, a single column, or a single stuff to your existing data frame, you can use the append. Now, because these two data, the data that we have, like I want to just add the second data frame to the first data frame, I can use the append method. So what I will do is that I'll put the first data frame, put dot, press tab. You'll see that we have the append method there. Append, and then you can put shift tab. You see, it tells you df1.append, then order, meaning the second data frame you want to put the df2. And then let's see other things we can do. We can also ignore the index. So we can set that. Let's copy that, ignore index. We can set that also to be true so that the index will function properly. So just set that to be true. And then you see, we've appended the first and second data frame together. But if you want to combine multiple things, then you have to use the concat. But if you're just combining just two data frames, you can use the append method. Okay? But that still works because they have the same column names. Okay? Now, before I move to how to work with different column names, you can also combine the columns instead, because what this is doing is that it's adding all the rows together. The first one, the data frame the data frame 1 is just A0 to A4. Data frame 2 is A5 to I think data frame 1 is A0 to A3, data frame 2 is A4 to A7, and data frame 3 is AA to D. So it's combined, it's just stacking up the rows together. But suppose you want to add them column-wise instead of rows. All you can do, let me tell you the parameter that is causing that for us. So put the same thing, concatenate, or press shift tab. There is this parameter called axis by default is equals to 0. Axis equals to 0 means combine my data row-wise, stack them up by rows. But if you want it by column, you have to set the axis parameters to 1. Axis equals to 1. And then you will see that you will have them stacked up in terms of rows, in terms of columns, sorry. We can also ignore the index like we have been doing. You can see now. So A, B, C, D, A, B, C, D, A, B. So this stack them up now by columns. You can ignore index. However, if you ignore index, you are not going to have column names. It will just be like 1, 2, 3 to 11 like that. Okay. Finally, how do we concatenate data frame that have different column names? Okay. Like so. What I did, remember I showed you that how to check your column name is using the columns attribute, like your data frame.column. So if you want to set the column names, just put your data frame.columns equals to them, pass the column names. However, the column names that you are specifying must be equal to the same number of columns that you have in your data. I have 4 columns in my data, 1, 2, 3, 4. That's why I'm specifying A, B, C, D. If you put it up to ABC, it's going to give you error because you have 4 columns and you want to specify, and you are specifying 3 column names. So I set that for each of the columns, A, B, C, D for data frame 1, E, F, G, H for data frame 2, A, C, F, H for that. You can check the data frame 2 just to see what you have. You can see data frame 2 is E, F, G, H as a column. So if you concat them together like we have been doing, like let me not store it in any data frame. Just put pd.concat, put df1, df2, df3. Now look at it now. You are going to have non-missing values which are stored as NaN. NaN means not a number. So meaning is putting, what it's doing is that is confused. You want to stack them up. However, it saw that for our ABCD, there is nothing that looks alike that under EFGH. So you just put them as NaN. So you will get missing values if you are trying to combine different data sets with different column names. So you will get NaN. How do you resolve that? Just combine data sets. If your data set have different column names, combine the one that share columns in common. When we do training on SQL, you see how to do that. Or even in R, there's a way to do that using the join parameter. But we also have the join here too. So there is a parameter that is causing this. If I put my shift tab here, my cursor there, put shift tab, you will see the parameter. It is the join parameter. And by default, the join parameter is set to outer. This outer means that combine all the rows together, all the data frames together. That's what join equals to outer. Outer join is doing. However, if you want to combine just if you want to use join equals to inner. What inner will do is that it's going to combine only the column that share things in common. But because in our data set, let's run this and see what we get. I'm sure we'll get empty data set. You can see it's empty because our columns, our data set does not actually share things in common, like A, B, C, D, F, G, H. They do not share. So that's why it's giving us empty. So what you can do, if you have different data sets, but have some columns in common and some not in common, combine the ones that share column, the same column names. Like I see here, like my data frame FE1 and 3, they share A and C together. So I can combine those ones. I can combine them. Okay, just comment out this. I can combine them, data frame 1, data frame 2, and use join equals to inner. Okay, we can also ignore the index. So if you run that, you can see you give it, you get the A and C columns because, and you have to use inner because inner there means combine the data with common column names, common features. So you have to select those data frame and then put join equals to inner, and then that will give you that. So I will postpone missing data, handling missing data to next class so that you can have time to walk through the exercise. Any question before I stop recording? Any question on what I've discussed so far before we start the breakout session? Any question, or can I stop recording? Can I stop sharing? Hello?
Mr. Kenny, thank you very much.
Yes, sir.
So yeah, I just wanted to, maybe this question is just, I don't know.
Okay.
But I wanted to ask, this Python machine learning field and all that, I mean, I believe with more practice, we'll be able to, get to a comfortable level, you understand? So looking at the different method and functions that I've seen here that we can use for different purposes, I want to ask that, do you think there can be specialization in this field? So I'm looking beyond what we are currently handling now, right?
Okay.
That's what I'm looking. Like I remember one time I asked you about application, like you can even build an application out of this and all that. So I want to believe that it's not so that anyone is not even overwhelmed. So I want to believe that it's not every of these functions and methods that we'll be using day in and day out. And if we keep practicing, we will get a good hand on this and be very comfortable with Python and machine learning. So this is a sort of a remark or comment from me. In fact, I was tempted to ask that, Mr. Kenny, please, how long have you been in this field? Your experience and expertise is just way beyond what I can comprehend right now. So Python is very new to me.
Okay, so let me say this and I will stop recording. Now, if it depends, it depends on the area you want to specialize. You can actually specialize. However, all these ones we are doing is general to any area you will specialize. Take note of that. It's because as far as you are, a data scientist is someone that derives insight from data. So as far as you are working with data, manipulating data, analyzing data, you are going to be using pandas. In fact, that's your number. In fact, embrace it as your love in this field. Your love in this field. Like you will love it. You will sleep with it. You will think of it. Pandas, if you will be working with data, because that's what you will be using it. You can now. Don't let the function overwhelm you. Remember I told you that you don't need to memorize it. Put dot and press tab. That's a secret that it took me months to learn. I'm telling you the truth. And that was why let me stop sharing before I say the next thing I want to say. Okay, let me just stop recording.
I'm laughing.